Hi, it's time for another math easy solution. We're going to discuss a derivatives example, and this one's going to be on basically finding a tangent line to a curve. And it's just to help illustrate doing derivative of power functions. Basically, the example goes as find an equation of the tangent line to the curve y equals x times square root of x at the point 1, 1, or x equals 1, y equals 1, and illustrate by graphing the curve and its tangent line. So now the first thing that we could do is actually simplify this function here, because this is the same variable x, so we could write it as y equals to, well, x times it by x 1 over 2. That's all the square root means, power of 1 over 2. Remember, this is an x, this is just also the power of 1 over 1, or since we could have the same number here, we could put 2 over 2, because we're going to have to add them up. Well, you could use chain rule, etc. I mean product rule, but we'll just use this instead. It's easier. So now we have this, and if you look at my power rule, I mean the power functions properties video in the video link below, you'll know that you could just add up these two terms whenever you have the same variable times it by itself in a power function such as these right here. So this could be x 2 over 2 plus 1 over 2, and this equals to, well, x. This is going to be now 3 over 2 right here. It's 3 over 2 because it's the same variable at the bottom. So we have this function. Now we've simplified it. Now we could apply the product rule. And the product rule, well, we just take a derivative. We just put this number down. So this is the derivative using product rule. You see video link below on proof of the product rule. This is going to be 3 over 2. And then x 3 over 2, and then it's a minus a 1, except once again we can to make it simplify was minus 2 over 2 right here. So this is just the same thing as 1. So whenever you do a product rule, right, so you always bring this power down and then minus it by 1 on the top. So this just equals to 3 over 2. This is just 3 minus 2, the same denominator, so we'll get 1 over 2 right here. Or write it down in square root form, 3 over 2 square root of x right here. So now the equation of the tangent line, well, this function's a power function, so it should look something like, yeah, something like, I'm just going to draw just a quick curve like that. It's not going to look like that exactly, but I just want to illustrate it here. So let's say if this is 1 and 1, so this point is 1, 1 right here, and then so basically we can find the slope, or to find the equation line we could just write y equals mx plus b, or an easier way is just to think about it in terms of a rise over run slope. And so if we look at rise over run right here, and we just pick a random point here, and this is going to be x and y, and then so basically the difference between these two is y over 1, and then this is going to be x over 1, so this difference, and then this one is this difference right here. And now the slope, if we let m be the slope, we know that m equals to rise over run, and then in this case we're going to have y minus 1 over x minus 1. So this x could be anything, and now the slope m is just going to be, well, the slope, and we know it's from a derivative. This is basically equals to y prime at 1. So here this is at the point here, because the slope's going to be the same everywhere for a line. So when we draw a line, the slope's everywhere the same. So if we have the same slope at this point, or in other words, it's tangent to it, so we just plug this in the derivative we have found out right here. So we just plug it in, and we are going to get y prime at 1 equals to, well, 3 over 2, and then plug a 1 in here as a square root 1. This just equals to 3 over 2. So we know what m is, so we just go 3 over 2 equals 2y minus 1 over x minus 1. So for any x value, we can find the equation of a line, and in this case we just solve for the y. So we'll get 3 over 2 x minus 1 equals 2. This is just going to be y minus 1. So simplified further, we'll get a 3 over 2, multiply that 3 over 2 inside, times the x minus 3 over 2, and then plus a 1, bring this onto the left side, equals y right here. And again, using common denominator here, times by 2 over 2, so that we can subtract. We'll get 3 over 2x. Now this part here is going to be a negative 3 over 2 plus a 2 right here over, because it's the same common denominator, or plus 2 over 2, and this is going to be a minus 1 over 2. So minus 1 over 2 equals to equals to y right here. So this is the equation of the tangent line to the point at 1 over 1 at the function of the function, this right here, y equals x 3 over 2, or y equals x square root x right here. And then if we were to graph it out using Google Calculator, yeah, so if we go to Google search right here and just write x times by square root x, and then the equation we found, 3 over 2 x minus 1 over 2. To graph both equations and then at the point 1 over 1. So this is a way to basically check our work. So add 1 over 1 and 1. As you can see from here, it is matching it perfectly right there. Just zoom in a bit more. Make this, so what would this be? So something like this. So basically there's 1, and it's basically really close to it. Zoom up. And here I've just copied and pasted that graph onto this Word file. So as you can see, there's the tangent line, and there is at the point 1 and 1, and this is exactly what we just derived. And so this is a way of checking it, and it is correct right here. And you could also write y equals mx plus b and then solve for y. Solve for m and b, we use it separately, but I'm not going to go over that one. This is a pretty easy method right here. Well, anyways, that's all for today. Remember, you can always download these exact notes in the Dropbox link in the video description below. And hopefully you enjoyed, and stay tuned for another math easy solution.